Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the molecular formula and degree of unsaturation. C8H14 has degree of unsaturation is equal to 2 times 8 plus 2 to 14, 2 is equal to 18 to 14, 2 is equal to 2. So the molecule has 2 degrees of unsaturation, example, 1 ring plus 1 double bond. Step 2. Understand the key conditions. I. Compound A is optically active, chiral, no internal plane of symmetry. 2. Catalytic hydrogenation of A gives a meso compound. The product has stereocenters but an internal plane of symmetry making it achiral. Step 3. Analyze option B1, 4-dimethylcyclohex, 2-Na with the 2 methyl groups in a trans, 1 wedge, 1 dash configuration. The molecule has a ring, 1 degree, and a double bond, 1 degree, total is equal to 2. Consistent with C8H14. With the double bond at C2, C3 and methyl groups at C1, wedge, and C4, dash, C1 and C4 are stereocenters. The trans arrangement means one methyl is above and one is below the ring plane, giving a chiral molecule, no internal mirror plane, optically active. This satisfies condition I. Upon catalytic hydrogenation, H2 catalyst, the double bond is reduced. The hydrogens add to the same phase, SYN addition. The ring becomes 1,4-dimethylcyclohexane. Because the starting material has the methyl strands to each other, one up, one down, the hydrogenation saturates the ring giving CIS 1,4-dimethylcyclohexane. The 2 methyls end up on the same side relative to the ring. Wait, let us re-examine trans 1,4-dimethylcyclohex 2Na on hydrogenation. With SYN addition of H2 across the 2,3 double bond, the existing trans relationship at C1 and C4 is preserved in going to 1,4-dimethylcyclohexane. Trans 1,4-dimethylcyclohexane is actually a meso compound because C1 and C4 are mirror image stereocenters with an internal plane of symmetry bisecting the ring. This satisfies condition 2. Step 4. Why other options fail? A. 1,4-dimethylcyclohex 2Na with both methyls on wedge. CIS. This is a meso compound itself, has an internal plane of symmetry, so it is not optically active. Fails condition I. C. The structure shown has a gem-dimethyl group, 2 methyls on the same carbon, with a ring double bond. This would not produce a meso compound upon hydrogenation. No new stereocenters created in a useful way for meso. D. Ethylbenzene, C8H10, not C8H14, does not match the molecular formula, and hydrogenation of a benzene ring does not straightforwardly give a meso product under simple catalytic conditions described. Step 5. Conclusion. Option B. Trans 1,4-dimethylcyclohex 2Na with methyls in opposite orientations is optically active and gives the meso trans 1,4-dimethylcyclohexane upon hydrogenation. Therefore, the correct answer is B. Therefore, the correct answer is option B.